doing a little bit more difficult equations. Lucy, no, you probably won't get a follow back. Unfortunately. Okay. So remember what we spoke about on Tuesday was we said we always want to get our variables by themselves on one side. Which side, it doesn't matter. As long as our variables are by themselves on one of the sides of the equations. And remember, how do we know we're dealing with an equation? Well, when there's a left-hand side and a right-hand side. And when we solve these equations, we need to use inverse operations. And so just to do a quick recap, if we look at this question I have on the board, it is x plus 6 equals to minus 3. Okay, cool. So x plus 6 equals to minus 3. What we said is we want to get x by itself. So to get rid of my plus 6, I can minus 6. But because I've minus 6 on this side, an equation is kind of like a fraction where what you do on the one side, you must do on the other side. So I minus 6 on my left-hand side, and because I did that, I have to minus 6 on my right-hand side. And now why did I minus 6? I minus 6 so that my plus 6 and my minus 6 could cancel out. Okay, and then I'm just left with x is equals to negative 3 minus 6, and x is equals to, somebody tell me what is negative 3 minus 6? Uma, we are only starting, so this is the easiest of the examples. We have 9 and we have negative 9. Not negative 3. Negative 9. It is negative 9. How do we get that? Well, if you remember, when we do our number line, we can draw a number line. We'll make this 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. We know this is how a number line goes, and this would have been 1. When we are trying to use our number line, we start with our first number. We start on negative 3. And then I have to subtract 6. When I subtract on a number line, I move to the left. And so I'm going to move 6 times to the left, 3, 4, 5, 6. And I just erased all of that by mistake. What do we end up with? We end up with negative 9. And so the answer there for us is negative 9. Our next series of lessons is geometry. Cool. So that is negative 9. The other method I then told you guys yesterday is the shortcut to this method. Instead of doing minus 6 on both sides, we can do what we call transposing. When we transpose, what we do is we say, okay, we have x plus 6 equals to negative 3. Now I know I want my x to be by itself. So I need to take my positive 6 and I need to move it to the other side of my equation. But when I move a number over the equals to sign, my sign changes. So it becomes negative 3 minus 6. I move it over and then I change the sign. You guys should be very, very careful that you can only do this transposing with plus and minus. Okay, and then you'll end up with the same answer here of x equals negative 9. Okay, so I hope we're all happy with this. We all remember this from last week. Thank you, Amicia, for that thumbs up. Now we have a different example. Now we have 3x minus 10 is equals to 2x plus 10. And now I just want to make this bigger for us. Now, I know this can be sort of confusing because you're like, well, we want to get x on one side, but there's x on the side and there's x on this side. So what am I supposed to do? Well, you get all of your x's on one side and all of the not x's on the other side. So what I'm going to do is I'm going to say, well, I want 3x to stay on this side. And then I want to move this 2x over to this side. And so when I move this 2x over, I have to change its sign. Okay, and so it's now 3x minus 2x. I still have minus 10 on that side, equals to 10. Now, I don't have my x's by itself just yet. What I have to do is I still have to take this negative 10 away from this side. And so now what I do, I transpose my negative 10. It's going to be 3x minus 2x equals to 10. I take this other 10 over, and when I take it over, I change the sign into a plus. And now what? Now, well, here comes some rules from expressions. Over here, I have like terms. Remember, like terms are terms where, so we have like terms. These are terms where we have the same variable and the same exponent. And so you can see over here, 3x and 2x are like terms. Why? They have the same variable of x, and they have the same exponent of 1. Remember, there's this invisible exponent of 1 up there. And so when we have like terms, we can subtract or add those like terms. And 3x minus 2x is going to give me what? Can you guys tell me 3x minus 2x? What's the answer to that? 1 what? X, right? It's x. So it's 1x. And I know I don't have to write the x. I don't have to write the 1. So I just leave it as x. And then 10 plus 10 is going to give me 20. So that is how you do this. When you have multiple variable terms, multiple terms with variables, you get all of those terms together on one side, and then they'll be like terms, most likely. So then you can add them together to simplify that. Now, what I want you guys to see is you could have done the transposing in one step. You didn't have to do it in 2 steps in the way I did it. But when you're starting out, I do think it's easier to do it one step at a time, just to avoid making silly mistakes like forgetting to change signs or, whatever it might be. Full answer is x is equals to 20. Very well done, yeah. Okay. Are we all happy with this? Okay, I see lots of thumbs ups. I see a hand. Do I see a hand? Let me check. Um, no, I don't see a hand. Okay, so that is cool. Any questions, guys? If you have questions, feel free to ask. You know this. I definitely never get mad at questions. I love questions because it means you're understanding and you know where you're not understanding. Okay, we have another one now. So let's now try do it all in one step. I see I have 9x on this side. I see I have 7x on this side. I know I want those to be on one side together. Then I also see I have positive 3 and I have positive 13. Those I want to be on one side together. So let's go ahead and let's transpose in one step. So 9x is going to stay where it's at. And then I'm going to take the 7x over to this side. And that is going to become minus 7x. Okay? Then I'm going to put my equals to sign in. I'm going to have 13 on the side. 13 stays on the side where it's at. And now I bring the 3 over to the side, and that becomes a negative 3. So, Bree, I saw you had a hand raised. Yes, do you have a question?
Hi, and sorry for disrupting.
No,
Um,
it's just Bree.
I have a question, ma'am.
Mm-hmm,
Like when we're grouping the like terms together in order to
mm-hmm,
be able to calculate it,
mm-hmm.
why do we have to change the sign?
So when I put 9x and 7x on on the side over here.
Yeah, because we had a positive 7x, and
Uh-huh.
then now it had to change the sign to a negative
Mhm.
7x.
Okay, good question. Remember, there's a difference between expressions and equations. In an expression, you have something like this. You have 9x plus 3 plus 7x plus 13, right? And there's an equals to sign here. And there's nothing on the left-hand side. And then if you were to rearrange it, you could go say 9x plus 7x. And that's perfectly okay because you just move their positions, right?
Yes.
And you could say then plus 3 plus 13. This is what we would have done if it was an expression. But now we are dealing with an equation. And how do I
Mm-hmm.
know I'm dealing with an equation? Remember, we said when we have an equation, there's this equals to sign in the middle that separates my sum into a left hand side and a right hand side.
Yes, ma'am.
Okay. So now, because I know this is an equation and not an expression, there's different
Mm-hmm.
rules that apply. So I can't just move my 7x around like I can in an expression. In an expression, it's perfectly okay to do that. But in an equation, when you move something around and it crosses over this equals to sign, it has to change the sign. That is just the rule. And if you look at where that comes from, remember I would have gotten rid of the 7x. And to get rid of the 7x, I would have went minus 7x. And then this minus 7x would have cancelled. But because I minus 7x on this side, I then also have to minus 7x on the other side. Do you see how I did that?
Yes, ma'am.
So what I'm doing here, when I just move it around and change the sign, it's just a shortcut for doing what I just did, getting rid of one by minusing on the one side and minusing on the other side. You see that?
Yes, ma'am.
Does that answer your question?
Yes, it does. Thank you.
Pleasure. Okay, so now we have on our left hand side, now we have 9x minus 7x. Can you guys tell me in the chat what is 9x minus 7x? Not 3x, 2x, there you go. It is 2x equals to, and then 13 minus 3, what does that give us? 10. Noctula, if I remember correctly, is Tando. Now what do? I don't have x by itself as yet. It's 2x. How do I fix this? Can anybody tell me that? We have Nkuli who's raised her hand. Yes.
Sorry, ma'am. That was an accident, ma'am.
Okay, no problem. Emilia, yes.
Good evening, ma'am.
Evening.
So, ma'am, what we're going to do is, so since 2x means 2 times x, we're going to divide 2x and 10 by 2, ma'am.
I am so happy to hear you say that. And you've done the explanation for me. 2x really means 2 times x. So remember, we use inverse operations to solve our equation. So to get rid of this multiplication, I have to do division. My multiplication by 2 and my division by 2 cancels. And then I'm left with x at the bottom. And then immediately I finish off for us. What is 10 divided by 2?
5, ma'am.
It is 5. 100%. Thank you for that answer.
You're welcome, ma'am.
Okay. Another one done. Questions on this? Is anybody confused? Are we happy? You can react with some happy faces or thumbs ups as you guys are doing already. Pussy is laughing. Great. Okay. Happy to see that. It's also, I'm very aware now that we have Happy in class with us. Happy, you'll see I say your name a lot. I'm always saying the word Happy. Okay, cool. Let's move on to the next one. I think this is the last one before our brain break, which is right on time. So we have, and let's do this 2 ways. We'll do this the long way, and we'll do it the transposing way. So if I was to do this in the long way, ma'am, how did you get the 7x to be a negative? Immediately, this negative 7 over here, are you talking about that?
Yes, ma'am.
Okay, so I kind of explained this like in a lot of detail. So I'm gonna tell you to go back to the recording and rewatch like 5 minutes ago. Rewatch that explanation, but I will explain it again, but obviously not in so much detail. But what basically happened is I said there's a difference between expressions and equations. When we deal with expressions, we have this, right? Where there's just an equals to sign that you write, and then you write all of your answers on the right-hand side. Now,
Yes,
what
ma'am.
happens with expressions, it's perfectly okay if you move the 7x to be closer to the 9x. You can move it around and it'll still be that positive x. But when we have an equation, there's different rules that apply because it's two different things. An equation is very different to an expression. And so
Yes,
what
ma'am.
happens is an equation is actually two expressions that we are saying are equal to each other. And so what happens is, remember the goal here is to get my variable by itself. So in order to get the variable by itself, I had to get rid of this 1 over here. And so to get rid of the 7x so that there's just one variable left, to get rid of my 7x over here, I would have minus 7x. You with me there?
Yes, ma'am.
Those 7x's would have cancelled out. And then, because we're dealing with an equation, what I do on the right-hand side, I must do on the left-hand side. And that is how we got the negative 7x on my left-hand side. You seeing that?
Yes, ma'am. I see now.
Cool. And
Great,
it will
ma'am.
be explained again, no problem. I'm going to explain that again now on the side. So we have negative 3x plus 4 is equals to 3x minus 8. Okay, if I'm doing this long method, I know I want to get my variable by itself. I see, okay, I kind of want to get rid of this one because this one is negative. So it's easier for me to keep a positive x over here so that I don't have to deal with a negative x. So in order for me to get rid of this negative 3x, I was going to say plus 3x. But because I did plus 3x on my left-hand side, the rule goes that I have to plus 3x on the other side. And what happens is that my negative 3x and my positive 3x on this side cancel out with each other. Because think about it. If you say minus 5 plus 5, it just cancels out and gives you 0. So my negative 3x, positive 3x cancels out on this side. And then what am I left with? I'm left with 4 is equals to 3x minus 8 plus 3x. And then I know, okay, let's take the 8 out of the side. So it's going to be To get rid of my negative 8, I know I want to plus 8. But because I've now plus 8 on my right-hand side, I must plus 8. And I'm adding this positive in the middle because I know 4 is a positive. I must plus 8 on my left-hand side. My negative 8, positive 8 on this side cancels. Now what am I left with? I'm left with 8 plus 4 equals to 3x plus 3x. I know 3x plus 3x is going to give me 6x. 8 plus 4 is going to give me 12. 6 times x, to get rid of that multiplication, I have to divide. Remember inverse operations. Multiplication, division by 6 cancels. And then I get x is equals to 12 divided by 6 is 2. And to write it in a nicer format, I'm just going to say x is equals to 2. Done and done. Okay, now if we're transposing, it's a lot quicker, but sometimes a little bit trickier. So we have negative 3x plus 4 equals to 3x minus 8. Well, I know I want to get my variables on one side, so I'm going to go 3x and 3x needs to be together, and then I want 4 and 8 to be together. So what I'm gonna do is, again, I don't want to take my 3x over this side. Why? I could, but it's gonna be harder because when I take it over, then my sign is going to change, and then I'm gonna have negative 3x and negative 3x, and then I'm gonna have negative 6x. I know I don't want a negative x answer, so I'm just gonna go, to make my life easier, I'm gonna take x over to this side. And when I do that, I end up with 3x plus 3x on this side. Then I'm going to take this negative 8 over to the other side. So I have 4 right now on this side, but I've taken the negative 8 over. When I take it over, it becomes positive 8. And then we have 4 plus 8 is 12. 3x plus 3x, 6x. Divide by 6, just like we did before. We get 2 equals to x, and in a nicer format, x is equals to 2. Okay, yes, Bree.
Hi again, ma'am.
Hi.
About the transposing method, I kind of understand, but I don't. Like,
Mm-hmm.
generally speaking, for other equations, I don't know if I'm about to make sense.
Mm-hmm.
How do you know what to swap and how to swap it? Or, like, how do you know in an
Okay.
equation that you don't want a negative answer?
Mm-hmm. When you're starting, you don't know. Because I've been doing equations for ages and ages and ages, I can tell before I even do it, you know? When you're first starting, you're gonna take 3x, and let's say we did that. Let's look at it. If I did it the other way around, what would have happened? It doesn't matter which side you take it over to. You're still gonna get the same answer. Some ways are just longer than others. So if I left negative 3x on this side and took this 3x, do you see, Brie? I would have taken it over and it would have become negative 3x.
Yes, ma'am.
Then I have negative 8 on the side, and I'm bringing my positive 4 over. And when I bring it over, that becomes negative 4.
Yes, ma'am.
Negative 3x minus 3x is negative 6x. You see that?
Yes, ma'am.
Negative 8 and negative 4 is negative
Negative
12.
12.
And then I would have divided by negative 6 and divide by negative 6
Yes.
gives me x is equals to 2.
Okay, ma'am. Thank you.
Pleasure. So now you guys can see it doesn't matter which side you take it over to, as long as you have your variables on one side and your constants on the other side, you're going to get the right answer. Some ways are just longer. And also with this way, if you struggle with integers, it's going to be harder to say, okay, what's negative 3 -3. What's -8? -4. So that's why I find dealing with positive numbers is easier. But when you're starting, you don't really know. So you just do whichever way is easiest. Rory-san, yes.
Mom, just booking order for the brain break.
Very smart. Okay. Rory-san, it's not what you think it is. It's this thing again. Okay,
Wait,
so
ma'am,
that
can I do the
officially
last one, ma'am?
starts. Okay, you can do that. I think the last one is hard. I think. I can't remember.
Nah, this is harder.
Okay, so we're doing guess the phrase, guys. Um, yeah, so I don't know how to explain it other than it's a picture that also represents a phrase. I see hands. Who is first in our queue? Let me look. Roy-san was first. Liaho is next. Yes, Liaho. Do you know what it is?
Ma'am, I'll go for the second one, ma'am. Someone can go
Okay.
first.
Imise?
Ma'am, I'm guessing it's going like going around, going in circles, maybe.
Going in circles. And I saw Itandile also put that in the chat. So well done to you guys. It is. It's going in circles. It's literally the word going in circles. You see that?
Yes, ma'am.
Thank you for that, Emilia. Okay, we have our next one. Liako, you booked the second one. I don't know if you're gonna know this one.
I don't
You
think
were
s
close.
I don't think so, ma'am.
It's not so hard, Liako.
Yeah, ma'am, I can see. Because, ma'am, this one, ma'am, says father, but then looks like it's with steps. Is it
Yeah.
father, stepfather, something like that?
Stepfather, there you go.
Oh, yeah.
If you said father step, Liako, I was gonna laugh at
Oh,
you.
yeah. Yeah.
Stepfather, that is correct. Thank you, Liako, for that one.
Thank you, ma'am.
This one is hard. I put this one in and I didn't even know what it was. I didn't get it. I had to look at the answer. I had to look at the answer. So if any of you get it, honestly, you get a gold medal. Gold medal for anybody who gets it. Also, I saw William, Noctula Tando, Bree, Itandile. You guys all got stepfather. Well done to you guys. Anybody? Any ideas? I don't even see hands. Meme red boxes. No, not quite. Not quite. You are a meme. Bree, you're getting somewhere. You're getting somewhere. Your first two words are correct. I'll tell you that. Bree's first two words are correct. Red meme. You are funny. No, not red meme either. Okay, how many Y's are there? Itandila, yes.
Ma'am, good afternoon. Ma'am,
Afternoon.
I think it's you are
Mm-hmm.
a red.
Okay. Also, the color has nothing to do with it.
How?
Yeah, but
Like,
I took it off of a red background, so I didn't feel like editing it out. So here it is. Okay, so the first two words is you are. Okay.
that I have to take it. Yes,
It's on delay.
Yes, ma'am.
Ooh, William's first
Mommy,
three words is correct. William's first three words. You are two. You are
You're
two.
too mean.
No, no. How many Y's are there, Itandile?
Two.
So you are two Y's.
I,
Two Y's? Two Y's? You are two Y's?
wow.
Two Y's. And then how many me's are there?
Two.
No, me's? How many me's?
4.
4. So put it all together.
You are too wise for me.
There you go. There you go. Thank you, Itandile.
It's my pleasure.
And Rorisang, you are up next. Oh no, this is not the last one. I take it back. But if you want to do this one, Rorisang, you can.
I'll do it, ma'am.
Hmm?
Actor, ma'am.
No.
Blue. Yeah. Act. Yeah.
So
And why did you make this hard? Yeah.
Amo has the right word in the chat. The word is supposed to be action. But what's missing? What letters are missing?
Act. Soon.
No. No.
You act.
In. Okay, William has the words that's missing. The word is supposed to be
Let me go to the
action,
chat.
but in is missing. In
Oh,
action.
act. Act. Yeah. Act. Eh. Blue action.
No, Rory, sign. So we have in and we have action. But do you see that in was missing?
Oh, wait. In action. Blue.
So no, so it's not blue. It's not blue. It's I can't believe nobody is getting
In action.
it.
White.
No, the color has nothing to do with it. Again,
In action. Letter.
it's missing, guys. The key word here is missing. I gave you a very big clue, Rory-san.
Yo. I.
Think of the 3 words you have: action, in, and missing. There we go.
Missing
The
in
chat.
action.
There you go.
Yo, they
Rory-san.
got it before me. Yo.
Well done, guys.
That
And
was
the
tough,
chat.
man.
It was, but I don't understand because when I first gave you guys these, you guys got it like this. So I was like, okay,
They
I
were
have to give
easy.
them. I have to give you guys harder ones. Now the harder ones, you guys are like, you guys even give up.
Ma'am, go easy on us. We're like kids.
No, but when I go easy, then you guys tell me, ugh, man, what is this? So now I
Yeah,
can't.
yeah, that's kind of facts, yeah.
Exactly. Thank you, Leah. Okay. Rory-san, if you're still here, I see also Imikle and Itandile. I don't know who wants to answer. If you have the answer, maybe put an emoji in the chat, a reaction, so I know to talk to you. You can give us the answer. Imikle is close. It's not worth reason. You're very close. You're missing one word. Or not one word. You're missing
Ma'am, is it without reason, ma'am?
not without reason. It's sort of like the opposite of that.
With no reason.
Mm-mm.
Um,
What's the opposite of out?
within a reason.
Within reason.
Wow.
Thank you, Imikle. You were close. You were very close. Without reason was a good guess, but it's literally the word with inside reason, right? So it's get it like within reason.
Yes, ma'am.
Okay, cool. That concludes our brain break for today, guys. I hope you guys enjoyed that. Honestly, it's quite fun to see you guys guessing. It's quite fun. And I know last time you guys fought with me and said, ma'am, nobody says these things. But honestly, I think you guys just live under a rock. I think you guys live on TikTok, you know? Maybe you should like open a book, you know? Yeah, we do. We do what? Jokes in the 1900s. A book in 2024. Yes, a book in 2024. Oh, we do watch TikTok. Yeah. You guys are watching TikTok. Maybe I must use like brain rot phases, you know? But anyways, moving on. We are back to maths. What do we have? You rather learn to dance on TikTok. Ugh, shady. Okay. We now have fractions, which is kind of scary, but also not really. We know what fractions are. Fractions just means division. What is the opposite of division? That was a hand. I don't know whose hand is up first. Let's see. Emilia, yes.
It's multiplication, ma'am.
Multiplication. So while you're here, do you want to help me, maybe?
I'll try, ma'am.
Okay. So right now, remember we said our goal with equations is we want to get x by itself. Okay.
Yes,
Right
ma'am.
now, I see this 3 attached to x, but that's like a later problem. For now, this fraction is bothering me. I want to get rid of this division by 4. How do I get rid of division by 4?
You times by 4, ma'am.
You times by 4. So I'm going to go 3x divided by 4 times by 4. And if I times by 4 on the left-hand side, what do I have to do? What do I have to do on the other side?
You also have to multiply by 4, ma'am.
I also have to multiply by 4. And then what happens?
Wait, ma'am. So 4 times 4 is 16.
So remember, this is not 4 times 4. I've multiplied this entire fraction by 4. So this is basically division by 4 and multiplication by 4. So what happens when I say times 4 divided by 4?
Oh, it cancels out, ma'am.
It cancels out. And so what am I left with on this side?
3x, ma'am.
3x. And now the other side?
24, ma'am.
24. Good job. And now, Emily, now what?
So, ma'am, since 3x
Mm-hmm.
means 3 times x, you have to
Mm-hmm.
divide 3x by 3 and 24 by 3.
Mm-hmm.
So
And then
it's going to be x
mm-hmm.
equals 8.
8. Very, very well done. Thank you for helping me, Emily.
You're welcome, ma'am.
Also, I didn't see Liaho physically holding up his hand, but that's really funny. That is really funny. Now, I want you guys to see, this is one method. This, I feel, is the easiest method. But there's many, many other methods to do this. You guys have to do the method that makes sense for you. So what I could have done is I could have said, well, 3 over 4x. Because remember, 3x over 4 is the same thing as 3 over 4x equals to x. I could have said that this means it's 3 over 4 times x. So to get rid of this multiplication, I divide by 3 over 4 and then divide by 3 over 4. And then you could put it in your calculators and you'll see 3 over 4 divided by 3 over 4 gives you 0. And 6 divided by 3 over 4 gives you 8. And you would have gotten your answer as x equals to 8. So that's another way to look at it. The other way to look at it is you could have looked at it like this and you could have gone 3x over 4 is equals to 6 over 1. When I have fractions in an equation, what I can do is I can make my denominators the same. So to make my denominators the same, I could have multiplied by 4 over here and multiplied by 4. Okay, now remember, because I'm making my denominators the same, I'm not actually changing the equation. So because I'm not changing the equation, I don't have to also multiply by 4 on the other side. So what would have happened here is I would have had 3x over 4 is equals to 24 over 4. And in an equation, what happens is when we have an equation with all of our denominators the same, what happens is we can literally just drop denominators. Why is that? Because I'm basically telling you what over 4 is equals to what over 4. Obviously, these numbers have to be the same. This number has to be equals to this number. So when my denominators are the same, my denominators sort of become irrelevant because it means then that my numerators have to be the same for those fractions to be equal. Okay, so in an equation, I can just drop my denominators. Now keep in mind, you can't do that in an expression. But in an equation, when you have all your denominators the same, you can just drop your denominators. Divide by 3, divide by 3. X is equals to 8. Okay, these are all the methods I can think of for now. Anybody with questions? Are we all happy? You guys can react for me to let me know how you feel. Yeah, who's happy? Imithle is happy. It's so hard to see the names through all of the thumbs ups. I see Shady. Itandile is not happy. William is not happy. What's confusing? What is confusing? I think maybe we just need more practice. We just need more practice. The thing with equations is it's really just manipulating numbers. So in maths, there's so many ways you can manipulate numbers. So that's why there's so many methods to solve the same equation. But as long as you're using the correct mathematical principles, you're going to get the same answer. And so let's try practice another one. For those of you who are confused with the first one, if you come up with a question that you can ask me, you're more than welcome to. But in the meantime, we're going to practice with another one. Okay. This one is a little bit different. It's a little bit different because now I have stuff going on here in my numerator, but it's still the same thing. What I can see is I have division by 4. Now remember, my objective, the whole objective of an equation is to get my little x by itself. We want to get x by itself. And so to do that, I have to start sort of removing the terms. What I want you guys to see is we can't take this 8 and take it over and transpose. Because remember what I said. When you're transposing the pluses and minuses, the reason why we can only transpose when it's plus and minus is because we need terms. We need to transpose an entire term. And so if you guys remember when we spoke about terms, this whole thing is actually one term. So I can't just transpose only part of the term and only go and transpose this 8. That's not going to work because when I transpose, I have to transpose the entire term. So for now, I can't go and transpose. What I do see is I can deal with this division by 4 first. I can sort of get rid of my division by 4 by using that inverse operation. When I use that inverse operation, what happens is we go and we say, well, it's division by 4. So I'm going to take my 8 minus 2x over 4, and I'm going to multiply that by 4. What happens is my division by 4, my multiplication by 4 cancels. But because I've now multiplied by 4 on the left-hand side, I must multiply by 4 on the right-hand side. And so that is going to leave me with 4 multiplied by 4. And when I do that, Let's first see what I have left. I have 8 minus 2x on this side equals to 4 times 4, which is 16. I heard a hand go up, but I don't see it up anymore. Yes, Bree?
Ma'am, okay, where does the multiply 4 come from?
Okay, so I sort of just did it. Remember, like I said, we have our x, and the goal of this equation is to get x by itself. X equals to something, right?
Yes,
And
ma'am.
so we have to start step by step to reach our goal. So the first thing we want to do is get rid of the fraction. We want to get rid of that denominator. And so the denominator really is just telling us it's this expression on the top divided by 4. Do you see that?
Yes.
So because I see it's division by 4, I know I can multiply by 4 to remove that division. Do you see that?
Oh, okay, ma'am.
But because it's multiplied by 4 on the left-hand side, to keep my equation the same, I also have to multiply by 4 on the right-hand side.
Right. Yes, ma'am.
And then that's where that multiplication by 4 came from.
Oh, okay. Thank you, ma'am.
Pleasure. If you just saw me react really weird, it's because I almost dropped my bottle. Anyways, moving on. I still want to get x by itself, but now I see I have 2 terms over here. Because I see now it's 2 terms, now I can transpose my 8. Don't make the mistake of thinking your 8 is negative. Your 8 is not negative. 8 is positive. The sign in front of 8 is a positive. So I'm going to transpose it. And when I transpose, I'm going to have 16 minus 8 on that side. What's going to be left here is negative 2x. Let's simplify a little bit first on this side. 16 minus 8 is going to give me 8. And now, what do I have to do to get my answer? You guys can let me know in the chat. Divide by negative 2. Uma, very well done. Are these better now, Uma? Do you feel that this is challenging you? No. Okay. Then that just means you're going to do great. That means you are going to do great. And so 100%, we're going to divide by negative 2. Why? Negative 2x means negative 2 times x. To get rid of that multiplication, I use the inverse operation. I divide. Because I divide on one side, I must divide on the other side. And that is that. Yes, Rory-san.
I was asking if this subject is related to division of binomial and monomial.
Not for right now. When you start getting more complicated equations, you'll see that sometimes, yes, you will have to divide your binomials. But for now, no, not really.
Okay, thank you, ma'am.
Pleasure. Okay. And then we have multiplication by negative 2 and division by negative 2. That's going to cancel. X is going to equals to 8 divided by negative 2, as Emilia has told us, it's negative 4. How did I get that negative 4? It's a positive divided by a negative, which is going to give me a negative, and 8 divided by 2 is 4. And that is our final answer. Okay, now can you guys let me know, how are we feeling about this? Itandile and Rory-san, I see your hands. What I'm going to do is I am going to put the quiz in the chat super quickly. And I'm going to let everybody go if they need to go. And I'm going to take your hands after. So, everybody remember it's Thursday. It is a quiz day. So here is your quiz link. If you don't take the quiz link from here, you can take it from the Google Classroom. And then
Bye,
goodbye
ma'am.
to everybody who is going to leave. Bye. Okay, if you're staying, if you want to hear what these questions are, if you have a question, please stay. Let's see whose hand is up first. Okay, Rory-san is gone, it looks like. No, Rory-san is still here, but his hand is down. Yes, Itandile, what's your question?
Well,
Mhm.
I didn't use a method that you used, right?
Okay.
But then I got the same answer, ma'am.
Tell me what you did.
Ma'am, I said 8 minus
Mhm.
2x over 4 is equal to 4 over 1. Then on the side of 4 over 1, I said times 4 times 4. And then,
Mhm.
ma'am, I said 8 minus 2x over 4 is equal to 16 over 4.
Mhm.
Then, ma'am, it gave me 8 minus 2x is equal to 16. Then I
Very well
transposed,
done.
and then I
Mhm.
transposed, and it got me negative 2x minus is equal to 16 minus 8. Then I
Mhm.
said negative 2x is equal
Mhm.
to 8 over
Mhm.
negative 2, both sides, and it gave me x is equal to negative 4.
I am so happy that you got to this answer. Can you see? A completely different method, but you're using correct mathematical principles and you got to the same answer. So this is 100% okay and 100% correct, Itandile.
Yes, ma'am. Thank you.
Pleasure, thank you for that. And then let's see, I think I see Liaku's hand up. Liaku, you're still here. You
Bye,
said
ma'am.
bye so long ago.